here we have a fourth degree polynomial. We know it's fourth degree because there are 4 linear factors. Now, there are no numerical values in this polynomial, but I can still tell a lot about what the function might look like. For example, if I wanted to graph this function, this positive a, I know that because it's a positive a, that means my root must be at negative a, whatever that value may be. Because I don't know that value, I'll just place it on my negative x-axis, and I'll know that this is point A. The same thing with my positive b. I know that this is a positive b, so my roots or my zeros must be at negative b. So I'll put that on my negative x-axis somewhere over here. Again, we don't know the value, so we'll just guess for now. Negative c is telling me that there must be a root at positive c. So again, I'll just place it there for now. And finally, negative d tells me I must be somewhere on the positive x-axis. Alright, so I know that this is a polynomial, and my leading coefficient here, there's nothing there, so I know that it must really be a 1, which is positive, so I know my end result should be positive going up. So now I can finish out my polynomial, just getting an idea of what it might look like. From there I can tell them some more information. I can find the x-intercepts. It crosses the x-axis here, 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 and here. So it crosses the x-axis at negative a, negative b, c, and d. I could even write that as their coordinates. Just to be more specific. Now my y-intercept, I see that it's crossing the y-axis right here. But this one's a little bit tricky because I don't know where that is exactly. But on my y-intercept, right here, I do know that the x value right here is 0. So what I can do is use my equation and plug in x to be 0. And if I do that, I can start to simplify the values that I do have. 0 plus a is a, and so forth with all 4 of my linear factors. A positive times a positive is a positive, times a negative is a negative, times another negative brings me back to positive. So altogether, I'll have a times b times c times d coming out positive. Whatever this numerical value is, once I know my numbers, I can multiply the 4 together, and that would tell me my y-coordinate right here. So my y-intercept ends up being 0, a, b, c, d. Seems kind of strange, but once I know the values, I could just substitute them in. And lastly, I could tell my end behavior. Your end behavior is what's happening at either ends of your function. So what's happening here on the left side and what's happening here on the right side. Got the R. So my end behavior over here on this left side, it's going to the left and up. Left and up. And on the right side, it's going to the right and up. The way we write that mathematically, left is our x-axis. So I say that x is going to negative infinity because to the left is negative infinity. And to say up, y is up and down. So y is going up, which would be up here would be positive infinity. Similarly here, we can write this in math language as well. X is our right and left, so we can say x is going, this time we're going to the right, which is positive infinity. And y, we're still going up here, and up would be represented as positive infinity. So you can still tell what your function is kind of going to look like, the x-intercepts, the y-intercepts, and the end behavior, even though we don't know the numerical values of our function.